So hello everyone. Now let's move forward today with the examples and some problems based on Cartesian product. So as you can see, here we have just taken an example and there are some different terminologies which needs to be defined and their understanding. So the first example is we are given two non-empty sets A and B with their respective elements. We are asked to find their Cartesian product, and which is very simple. We can easily calculate it using the definition defined in the previous lecture, which is nothing but simply this one, this set. These ordered pairs. And this one, final one. So in all you can see that A cross B, the Cartesian product consists of the following 6 ordered pairs. Now we are asking what is their visualization basically, but how we can interpret these Cartesian products. So if you now look here, this is our xy plane. This is only the one quadrant I have sketched. First quadrant of the xy plane, because in our case all the coordinates or the ordered pair are positive. So if I mark them on this particular quadrant, they lies over here somewhere. So the visualization of this Cartesian product or the elements, the ordered pairs, is that we can write it like this. The elements fine. So these elements, what are these elements? Basically every ordered pair correspond to an element for this Cartesian product. So in all there are 6 elements, 6 ordered pairs, and each ordered pair represent a point in this xy plane. We can understand it by plotting some of these points. Like in this in general I have expressed A and B. So in particular for this, suppose the first point, if I take 1, 1, now let me rub this. So somewhere this is our 1, and it is, let me take this point as 1 now, let me call it in blue. So now this particular point here, this one, this represents this ordered pair 1, 1. Similarly 1, 5, fix 1, increase the height till 5, suppose this is our 5. So basically I'm asking you to represent this ordered pair here. Likewise, in a similar fashion, you can plot the remaining ones. So this was the visualization or the interpretation of the elements of the Cartesian product. Now in general, we want to understand what the Cartesian product, the elements of the Cartesian product, the ordered pairs, in the plane, what they mean and how we can understand them. So the plane, this is just a one quadrant of the plane. If I now sketch the whole plane, if I extend these, this x-axis to the negative, and this is the negative part of the y-axis. Like this. So here is our origin, and then both axes are perpendicular to each other. So in general, this xy plane has a representation given by this symbol bold capital R2, which is a Cartesian product of this R cross R, this bold R, and this set which we have already studied is used to denote this convention is for the set of real numbers. Fine. So what we are asking here in the xy plane, the ordered pairs are nothing but the element of this form. In general, x, y, such that this x is an element from this particular set and this y is an element from this second set. So this x is an element of R, belongs to this set, and y belongs to this set. This is a set theoretic notation of our plane R2. If now I rub this notation, or let me rub this part, we will be defining what it is. Let me rub this one again. So we have understood how to represent the plane in terms of the Cartesian product, because if you now try to understand, this is the real line. simply the real number line which contains all the real numbers. Again, this is again a real line which are both perpendicular, and I have just marked some of the points on this particular plane. There are infinite points which we can mark, or basically we can understand it another way also. This plane consists of all those points basically, but this R2 is collection of those x, y such that this x is an element of R and this y is also an element of this particular set R. So this R2, this is the geometric interpretation of this, is our xy plane, which I have just marked over here. So it covers all the points. I am not sketching, it covers all those points, fill the whole of R2. Fine. So that particular R2, that plane can be expressed in terms of this Cartesian product, and we call it xy plane. And of course it is two-dimensional, and I give it to you problem, you have to find it yourself why its dimension is 2. We're going to answer in the coming videos, so it's an exercise for you. Drop in answer in the comment section. Fine. So this is how our plane can be understood in terms of the Cartesian product. Let's move forward with the next terminology which we have to understand, the order triplet. Let's define it above. Order triplet. All those points in the xy planes were ordered pairs. The order triplet is defined. Suppose, let's go forward to definition. Let A, I'm writing in short now, this means is non-empty set. Then the ordered triplet has this notation, and which is defined as all are coming from A now. Fine. So this is our set theoretic notation, contains all elements of this form. Now this set, this ordered, this is the representation for this ordered triplet, and it contains element of this form, and this is a triplet. Why they are called ordered triplet? Because they follow some order in the form of this. All the elements are coming from this respective set. Let's take an example to get a more clarity, and finally the visualization of the definition. We're going to understand. We can rub this one. Let's take an example. Let me call set P given by 1, -1. I ask you now to find P cross P cross P. Pause the video and try to find it yourself. So now let's try to find the order triplet P cross P cross P. This particular set you want to find for this set P. So how it is given? First we will calculate P cross P. It's very simple now. Take the Cartesian product of the P with the set itself. So basically I am asking you now this much of quantity you have to find. Simply you can easily find. This is this much. Now I am asking you to find the Cartesian product of the original set P with respect to this set, this particular set. Fine. So it is the Cartesian product of these two sets now. Observe now. First, let me mark this in black so that you can distinguish. This is the P now here. I'm talking. Although all are same, but just to give you clarity, I just use different colors. So you have to find this Cartesian product now. The Cartesian product of this set with this particular set. Use the definition again. Take the first element from the set P, and now the corresponding choice of the second element from this set. Now each element here is again an ordered pair, so it's very simple now. Corresponding to this one, this is the first element you get, whole of this ordered pair. So mark those elements. 1, 1. Now for this one, this is the second choice. Fix this one is from here. Now these two elements simultaneously. I hope you can now continue the process and easily find this triplet. I am now just writing it directly. Now choose -1 and apply the same process. Fine. So this is how we calculate this particular set. And of course, now we answer what the visualization or what this set, but we can interpret from this particular set. In the case of order triplet, it was a point in the xy plane. Now it is an order triplet, so it will be a point in the xyz plane, three-dimensional space basically. So now let me rub this one. Even I want to first give you an idea. This was our xy plane. Now I want another axis perpendicular to both the previous one. This is my z. Fine. Of course, you can understand I'm not now marking, but you got a clarity. All the three axes are perpendicular to themselves. This is a space, three-dimensional space. Now I'm talking. So this is the notation for this particular space: x, y, z space. Space simply R3, which is given by here. I have just expressed the definition of this space in terms of the order triplet, where each of the elements are real numbers. If you want to, like, you can rewrite it like this also, but that doesn't, we don't need such notation. For simplicity I write directly, but otherwise it is understood that this R3 is again a Cartesian product of the set of real number with itself 3 times. So this is this one, and fine. These are R3. This is geometrical interpretation. Any point now, any point. What is ABC basically? Suppose there is some A here, there is some B. Mark some point somewhere in this, on this z-axis, maybe somewhere here C. So these 2 points were A and B were like here. They were lying over here. Now because now the C point has now come into the picture. So what you have done here, you have given it a height corresponding to the point C. So if I call it like this, will be the point somewhere my A, B and C will lie. Observe here, these two are, this 2 point right now, this is a AB, and now it lies in the xy plane. This particular point lies in the xy plane. Now what you are doing here, how this point now went over here, you have increased the height of C, which you are not able to visualize, but try to feel the intuition. It's very easy if you like plot a point in 3-dimensional space. Let's take a practical example, right? Suppose these two are my perpendicular axis. Now this is my z over here. So this point is moving out in that sense. This is the height. So this is the C, which is the height you have taken on the corresponding z axis. Fine, that's why this point is now out of this particular xy plane and somewhere over here. Now this is the final example which we have taken. Here our 2 sets A and B are, if you just try to observe here, these are intervals. Our A is a collection of all those real numbers which vary from 2 to 3, and our B is a collection of those real numbers. Of course, they lie on the y-axis and they are on the x-axis. So our B is the collection of those real numbers which vary from 1 to 2 or 2 to or 3 to 4, which we have already studied while studying intervals in the very first chapter in the set theory. So you can refer to if you want to get a clarity on how this was defined. Now we are asking here how we can find what is basically the Cartesian product of these two intervals we want to find. So I now ask you to first sketch those two intervals in your copies and now try to find it yourself. Pause the video and try to find it yourself. What will be the Cartesian product? Now let's try to understand what this means in terms of the Cartesian product. Basically, I'm asking my x to fix between 2 to 3 and both are included, 2 and 3. So if you now sketch this particular strip this much, similarly likewise here, these are basically your lines x equals to 2 and x equals to 3. Now you want your x to lie between these two. So you have a choice for x varying from here to here. Or x can vary now, including both 2 and 3. But your y varies from 1 to 2. So this is your 1. This is your y equals to 1. Similarly, this is your y equals to 2. Fine. Now you're asking the Cartesian product. So it is a collection of all those points from the set A and the set B. So basically, in the first case, when I have fixed my y to belong to only this much and choosing my x to lie in this particular range, the Cartesian product is given by this rectangle. This again whole rectangle. If I now shade this rectangle, then you observe now here that the boundary is included in the boundary of the rectangle is included in the Cartesian product. Similarly, you can now vary the y from 3 to 4. It's very simple now. Likewise, I have chosen 4 to be far enough. Let's brought it down. If our 4 lies somewhere here, let me count this. These are 4, this height. So now the answer to this y, fixing these x, the Cartesian product is this rectangle, collection of all those points now. Because our y now varies from 3 to 4 and our x vary from 1 to 2, so these are all possible choice of the points in the xy plane which you have corresponding to the choice of the elements from the set A and B respectively. So these two shaded regions represent this particular Cartesian product in this particular case. So we can now conclude the today's video with this much of give good stock of examples and problems. In the next video, we'll be starting with precisely what is a relation and the terminology related to it, and moving further to functions later on. And please find a link below in the description to our Telegram channel for the IITJee mathematics we are preparing, as well as those who want to get good information regarding all the notifications and updates on our Facebook page. So all the important links and all the relevant important links are mentioned below in the description. So just have a look on them and just do subscribe our channel. Thank you so much.